Good morning, students. Today we are going to discuss some basic concepts about scalar and vector. So, scalar is a quantity which has only characterized by its magnitude. It does not involve any direction. So, for example, temperature in a particular place, we can say it is a 20 degrees Celsius like that. Similarly, mass, volume, density. So, all these are examples for scalar quantity. And second one, vector. A vector is a quantity which is characterized by both magnitude as well as direction. So it will be denoted by both magnitude and direction. So for example, force. So particular direction, what is the amount of force we can get. Similarly, for if the air velocity, wind speed considered, so in particular direction, the wind speed is this much. So it is the vector quantity. So displacement, field intensity. So these are the examples for vector. So scalar field, the distribution of scalar quantity with a definite position in space. So temperature in the space. So we all know about the temperature in the atmosphere is 30 degrees Celsius usually. So this is a vector field. Example for vector field. And then vector field. So quantity which is specified in a region to define a field is a vector, then corresponding field is called vector field. So in a particular region, any quantity is specified in the vector, then we can say it as a vector field. So already we told wind velocity, displacement of a flying bird. So these are all examples for vector field. So another important thing, unit vector. Suppose a vector b, take it as b is a vector, so which has both, so it is a vector quantity, so it will be defined by both magnitude as well as directions. So the vector magnitude we can write it as simply b or magnitude of b. So the symbol for magnitude is like this, we have to draw. So magnitude of b. So unit vector, we normally use the symbol a. So a suffix b means the vector b is a unit vector. Unit vector of b. Along b is defined as a vector whose magnitude is unity. The magnitude of the particular vector is unity, then you can say it as a unit vector. So the unit vector is defined in its direction. Which direction the vector b is acted, that direction it will be defined. So the formula for unit vector is b vector divided by magnitude of b vector. So the value, the magnitude of unit vector remains 1. Suppose the vector b is in Cartesian coordinates, we can represent bx, by, bz. Then you can written as bx into x direction. The unit vector is ax, y direction ay, and z direction az. So this is about unit vector. So here you see the example for unit vector. So here the vector, any one point the vector is specified. So here the distance from the origin is r vector. So the point here is located at the distance of ax in x direction, ay in y direction, az in z direction in this plane. So look at here. So ax, ay, az. So we can write the vector b is magnitude of b is equal to bx square, by square plus bz square. So the unit vector can be determined by a suffix b. So unit vector of b is equal to b vector divided by magnitude of b. So magnitude of b root of bx square, by square, bz square. So b by root of b. So this is the way we have to find out the unit vector of a given vector field. So here you take down this, obtain the unit vector in the direction from the origin towards point P, 3 comma minus 3 comma minus 2. So here in this problem they given AXS 3, AYS minus 3 and AZS minus 2. So you can write magnitude of P vector equal to square root of 3 square plus, so a by minus 3, so minus 3 square plus bz minus 2 square. So 3 square 9 plus 9 plus 4. So root of 22 you will get. So this is magnitude of vector P. So the unit vector we can calculate is P is equal to B vector. So B vector you can write 3 into AX minus 3 into AY minus 2 into AZ divided by, so the magnitude value we calculated as root of 22. So this is unit vector of given vector point P, 3 comma minus 3 comma 2. So tomorrow we will see about scalar and dot product and vector product. That is scalar product and vector product. So vector addition. Suppose I have two vectors, A vector and B vector. Now we can add directly the two vectors. The resultant vector may be taken as C. Now C is equal to A plus B. Suppose vector A represented by AX, AY, AZ as said earlier, and B is equal to BX, BY, BZ. Then if you add vector A and B, then the resultant vector D is equal to, so if you need to add X component with corresponding X and Y with corresponding Y. So AX, BX into AX direction, AY, BY in AY direction, AZ, BZ into AZ theta. Similarly, for vector subtraction also you can subtract with the same way as we did addition. So instead of addition, you have to subtract that resultant vector. So AX minus BX into AX, AY minus BY into AY, plus AZ minus BZ into AZ. So here actually Z AZ minus BZ into AZ. So dot product. So next we are moving to product. So product here it is a two type of product is there. One is vector product and another one is scalar product. So first we will see scalar product, or the another name for scalar product is dot product. So we will see what is made dot product. Suppose I am considering two vectors, vector A and vector B. Then the dot product or scalar product is defined as the product of the magnitude of A, the magnitude of B, and the cosine of the angle between them. Between them means the angle between vector A and vector B. Then we can say it as a dot product. So if two vectors are said to be orthogonal, that is, if the two vectors are perpendicular, means we can say A dot B is equal to 0. So according to our definition, what we define? Product of magnitude of A, that is magnitude of A vector and then B vector, cosine of the angle between the two. So cosine of the angle between means cos theta we can do. So cos theta AB. So what is the angle between A and B? We may denote it as theta hyphen AB. So what the condition they are setting? Suppose vector A in this direction, vector B may be in this direction, that is 90 degree. Then the theta AB is equal to 90 degrees. So cos 90 becomes 0. So the scalar product A dot B, the answer will become 0. So hence the A dot B, that is any two vector scalar product is equal to 0, we can easily understood that the two vectors will be on perpendicular to each other. This is the condition. So here we have to product like this. A dot B is equal to AX BX plus AY BY plus AZ into BZ. So this dot product has some kind limitation. That is, it obeys the commutative law. That is, A dot B will get the same answer as B dot A, and then A dot B plus C is equal to A dot B plus A dot C. So again, A dot A is equal to A squared. So while during multiplication, AX dot AY or AY dot AZ, that is different axis you can multiply, and you will get 0 as the answer. But same quantity AX, AX, AY, AY, you will get the answer as 1. So the main application for this case is it is used to determine the angle between the two vectors, and also you can find out the work done by the constant force expressed as the dot product of two vectors. Next we will move on to cross product or vector product. So that is symbolically it will be written by A cross B. Previously scalar product you can written as A dot B. Now we can written as A cross B. So scalar product A dot B. That formula I told A cross B, sorry, modulus of A, modulus of B into cos theta. Am I right? Cos theta. So similarly here A cross B is the vector product. So A cross B is equal to, the formula is similarly modulus of A, modulus of B into sin theta into, so vector product. So is a vector we have to denote. So n cap, unit normal vector also you have to point out which direction the resultant will be acting. So the magnitude of A cross B equal to the product of the magnitude of A and B and the sine of the angle between A and B. Here sine of the angle between the two. So A cross B is equal to, we can in matrix form we can easily write. So AX, AX, AY, Z. So first vector AX, AY, AZ. Similarly second vector. So in the scalar product we define that AX dot AX equal to 1. So but here it is 0. We'll see the properties. So these are the properties. So in dot product A dot B is equal to B dot A will be obey, but cross product will not be obey. A cross B is not equal to B cross A. So it will be minus B cross A. Similarly, A cross B cross C is equal to A cross B cross C. It's not obey. And then A cross B cross C is equal to, we can write A cross B plus A cross C. So A cross A is equal to 0. So while multiplication, look at the vectors. A cross A is AY equal to AZ, AY cross AZ is equal to AX, AZ cross AX equal to AY. So if you multiply in opposite, then the direction will be changed. So AY cross AX equal to minus AZ, AY cross AY, sorry, AZ cross AY is equal to minus AX, AX cross AZ is equal to minus AY. So if you multiply the same quantity means you will get 0. A cross AX equal to 0, AY equal to 0 and AZ cross AZ is equal to 0. So here sin theta. So if the two vectors are in parallel, then you will get sin theta, sin 90. If two vectors is parallel, then the angle between the two vectors theta is equal to 0 degree. So A cross B, what is the formula? AB sin theta. So sin theta, so sin 0. Instead of theta, the angle is 0. So you will get the answer as 0. So he, in this case, if you get the answer as 0 means you can assume that the two vectors are parallel to each other. So the two vectors are parallel, then you can consider A cross B is equal to 0. So this A cross X multiplication we can easily remember. Just listen, I will say the tricks. So by screw rule we can easily identify. Suppose take it as AX and then AY and then AZ. So assume the screw is rotated means right hand direction. So AX, AY and then AZ. This direction you rotate the screw. So if you multiply AX cross AX, then your answer will be AZ. Clear? In the rotation direction, the value will come now. You can take it as a positive. Suppose it's not like that. It will be opposite. Suppose I am multiplying AX cross AZ. So it will be opposite direction to your rotation of screw. So the answer should be AY, but minus AY you have to include. Likewise, you have to take it as this. So it's easy to remember by using the screw rule. Okay, thank you.